I'm Andrew Zolli. I'm in charge of what we call global impact initiatives at Planet, which means I oversee all of our work in sustainable development, public health, climate adaptation and resilience, scientific research, disaster response and recovery. And I thought I'd just say a couple quick things. I want to just show you this. Just because we've been talking about the one big question, and then I'm going to talk to you about space and satellites and some of the things we're doing, some of the ways in which you're all very attractive people in this room. I feel like you're slightly differently attractive cousin. Like we're familially related, and some of the things that space lets you do point the way to things we're going to be able to do with drones soon. Some of the things are different, and it's a useful to sort of think about how these different technologies complement each other. But before we go into any of the space stuff, I just want to show you a really quick thing, just to talk about the big question that Kippy asked, which is when, 5 years, 10 years. And so I wanted to show you just these two quick images to get started. This is the election of Pope Benedict. This is when they, all the guys in the hats get together and they burn a little thing and the smoke comes out and they go, "We have a Pope." You know that moment, right? Okay, this is that moment in 2005, the election of Pope Benedict. Here's exactly the same shot in 2013 with the election of Pope Francis. There is a subtle difference here, but if you train your eyes, let them go blurry for a minute, you will see the distinction. So what was the triggering event that happened between 2005 and 2013 that caused this very large-scale change? Does anyone have any idea?
Smartphone.
The iPhone, exactly. And we sort of say the iPhone, and I want to come to why we say the iPhone in particular, because I think it bears on questions about drone acceleration. But I want to show you the entire history of the interface of the mobile phone in one chart, which is, it looks like this. This is from 1990 to 2015. And what you notice is, like right in here, something really big starts to disappear. The tail, the vestigial tail, disappears, right? And we go from a device that has a screen, a communications device with a screen, to a screen that happens to communicate. Now, if you were an astute observer of this space, and the folks at Apple were, when you were back, roughly here, if you were lining them all up by the bestseller, you'd say, I have a pretty good sense of where this is going, and I have a pretty good sense of how we could get there. And what would happen if we accelerated ourselves roughly from here to roughly to here, right? Just really over this divide, this one right here. In many ways, that's what Elon Musk is doing with SpaceX and with Tesla. He's looked at the same trajectories and said, we're here, but we think we can get here, and the world will be dramatically accelerated if there is a mainstream, large-scale, well-financed competitor that causes all the other competitors to swim in this direction and accelerate that change faster. And that's what he's doing in batteries, that's what he's doing in electric cars, that's what he's doing in launch vehicles, and on and on and on. The interesting question is, where are we with the drone ecosystem? I would argue that we're really like kind of here. And one big observation I just wanted to share with you, it's a couple things I've been listening all day to our conversations. A couple threads have come up, but one of them is the difference between 2015 and 2017. Did you notice how many times people talked about just the shift that feels kind of pregnant that's happening right about now? Feels like it's in this space. The other thing that's I think really fascinating is how much significant acceleration occurred in the use of the humanitarian applications of advanced technologies as caused by kind of major triggering events. And I think about what the Haitian earthquake in 2010 did to dramatically accelerate crowdsourced, on the back of this, really, because when we were here, suddenly we were talking about crowdsourced crisis response, right? In 2015, we just heard the last one was in Nepal, right? We heard about it today. We heard about what went well and what didn't go well, and the way in which those kind of galvanizing events meet the technology. So those major events are a few years apart. So it takes time for the ecosystem to form, to respond, to fail in the face of an opportunity, but to get close and then to get galvanized. And I think that's roughly what's going on in our kind of sputtering approach as we get closer to this moment. But like, you should have no doubt, this moment's coming. And a good indicator will be when someone like Elon decides that it's going to happen everywhere, right? Or someone like Jeff Bezos, or on and on and on. When big players come in and say we're gonna build these things everywhere, and do it at industrial scale. Okay, so I want to talk a little bit about Planet and what we do, and then I'm going to give you a couple of examples, things that we've seen sort of peeked into the future a little bit, in part because the principal benefit of the drone ecosystem, and you heard it in use case after use case today, what is how much you can build with communities. You can build right up close. I mean, you just heard David, who, by the way, OpenROV and Planet, the organization I represent, started in the same garage, literally the same physical facility. That was not planned, I'm assuming, but, right? Think about what ROV does. It puts the technology directly in people's hands. It's a very intimate use of technology. Planet's development of technology is designed to ultimately yield intimacy with the data. But you don't get your hands as dirty with its actual manufacture. But as a consequence, it's more centralized, and we can begin to see the kinds of derivative things that come out of it, which will happen as we centralize what happens with the drone data, with the help of people like Anne and people who are doing Radiant and collecting all this open data into central places. So the mission of Planet, just really quickly, is Planet's purpose is to use space to help life on Earth. It's an enterprise that was founded with both a commercial and a humanitarian mission by charter. We're not allowed to violate either one of those, so they're designed to go together. Our first mission, and there are more than one mission for the organization, is to image the whole Earth every day and to make global change visible, accessible, and actionable. Now, you all know it's a satellite company, or some of you will know it's a satellite company. It's worth just saying a word or two about satellites. Typically, they're the size of school buses. They cost hundreds of millions of dollars to billions of dollars to make, decades to plan, conceive, deploy, and operate. And just like the mobile phone, that revolution took advantage, Planet took advantage of that enormous trillion-dollar research and development supply chain in consumer technologies to take a very different path. And the way in which we achieve that mission is by satellites that literally have a smaller wingspan than this object right here. So these are satellites that are roughly the size of a loaf of bread. They're called, well, in the satellite industry, because a lot of them come from the military, they're often named for birds of prey. So there's lots of talons and hawks and beaks. We call it the Angry Birds phenomenon. So these satellites are referred to as doves. They're named for birds of peace. You might notice they're covered in artwork. Actually, this is one strip of a much larger mural by one of our artists in residence that tracks it's a huge mural of all of these animals that make the Great Migration. So we laser etch images of the animals that make the Great Migration as they circle the planet looking down on us. What we do with these satellites, which are about this big, is we put them in a giant orbit that runs roughly over the North Pole, down between the sun and the Earth, down over the South Pole, up over the dark side of the Earth, and as the Earth spins perpendicularly underneath it, each one of them is a camera, and we collectively image the entire terrestrial surface of the planet every day at roughly 3 meters per pixel. So we're not competing with you in spatial resolution. You guys have that all over the satellites. But what we do have is the highest cadence, the most significant global coverage of imaging the whole Earth that we've literally ever had. And what can you do with that kind of technology? Well, I'm just going to show you a couple of quick examples. So one thing is you can look at very large macro scale change. And I'm going to end by talking about how the high resolution tasked drone systems that you run, and these systems can coordinate. But just to give you a sense, this is from last year, this is from March, and then you look into May. 60 days later, you can see literally on a daily cadence. I'm not showing you all the interpolated images, but just a sense of how much change there is. This is incredibly valuable because we look at every point in Peru as much as we look at every point in Palo Alto. This happens to be along the Madre de Dios. This is the Tambopata Reserve. This is illegal gold mining happening in the reserve. This is actually a protected area. And working with a partner organization that maps the Andean Amazon, we're able to track real-time illegal gold mining and related deforestation, sufficient actually to, this imagery ended up on the front page of the largest daily in Peru, and encouraged the Peruvian Coast Guard to go in and actually destroy all the activity, which is another part I'm going to come to. So some of the imagery is incredibly timely. You might have heard that in Sri Lanka, just over the weekend, there was a huge major flooding event. It actually continues. This is imagery from May 27th. It was released on May 28th through an entity called the Planet Rapid Response Team, which we actually worked with Patrick and the Digital Humanitarian Network to train a cohort of volunteers. And that gives you a sense. So this is large-scale imagery from May 22nd. This is the same imagery from May 27th, just to show maximum difference between them. So this is particularly valuable because drones can't see everywhere, and because if we need to deploy them to the most important places, it's useful to have a sense for what's changed. So this is a giant, global, persistent, remote monitoring change detection engine for the planet. If we can give you the tools for understanding where the changes occur, then you can actually go to do higher resolution mapping if the application is a mapping application, much higher resolution mapping where it's needed. And it's useful for all kinds of other things, including monitoring the new open corridors that we're starting to see in new places like Malawi. We're also using it to look at much slower forms of change, in this case in Dar es Salaam. So Dar es Salaam is growing, like many cities in the global south. It's actually growing, well, no one's really sure. Some estimates have it at about 3% a year, some are about 9% a year. And the urban monitoring, urban civil decision-making authorities, the kind of urban planning authorities, don't actually have firm estimates. So what we're doing is we're taking data sets that were collected on the ground through OpenStreetMap, and a bunch of drone data, and the satellite data, and we're tracking the emergence of new building patterns. It's actually one quick characterization. It's literally data that has been shown, it was just shown for the first time 2 days ago in Dar es Salaam. And all this is going to end up with the flying labs. So we're going to try and provide all of this infrastructural imagery as an asset. And I'll talk more about that in a second. Okay, we can see the emergence of IDP camps around the world, both formal and informal refugee camps all over the planet. We can watch real-time deforestation occurring, and you should just look at a sense of the time axis. This happens to be in Bolivia. Over weeks, you're looking at hundreds of hectares of forest being destroyed. Now, when you have the whole Earth every day, and you have the day before, and the day before, and the day after, and the day after, not only do you see the signs of change, but increasingly, you see the pre-indicators of change. So for instance, in the realm of deforestation, what you often see are roads that go in before. Okay, right, thanks. That's when yes. Yeah, I'm very happy nothing happened here when that occurred. So, so what's really powerful is that you can't, because the Peruvian Amazon is so large, it's very hard to monitor on a daily and weekly basis, which means that often our decision-making, our data is outside of the decision-making cycle. So this begins to put very large-scale data sets into the decision-making cycle in a way that perfectly sets up and will drive demand for drone flights. It'll drive demand for more calibrated drone-oriented activities and really correlate with each other. Now this is the other thing, and again, we didn't actually, where's Dave? We didn't actually coordinate this, but I want to show you a very similar thing you just saw with the fishes. So what we're doing is we're also building large-scale computer vision algorithms that allow us to look at infrastructure and look at forms of change on the Earth as a whole. So I'll give you one example. This is in China, and this is a visual search engine that's looking here at solar installations and finding every similar solar installation right now in China. So that's China literally in one day, everywhere at 3 meters. That's other solar installations. So if you wanted to monitor infrastructure or you wanted to monitor deforestation, these are the kinds of assets that we're going to have. All of this data is going to eventually drive very large-scale kind of search engines. Which leads me to this basic idea. All of us in this room, but especially those of you who work with drones, have a ton of data pipeline issues. You just produce vast amounts of it, you run out of terabytes. We produce something on the order, we're going to be producing something on the order of 13 terabytes a day, just for those of you who have to deal with large-scale data issues. This is why people are literally moving data around by truck rather than fiber optic cable. We're producing so much of it. But I really believe that period is going to be transitory. And we have this basic mental model we use a lot, which we think of as one of the things that drives us over that hurdle, the mobile phone hurdle, into the new era, in which we really believe that the period of big data will be transitory and is likely to be replaced or supplanted or at least augmented by an era of big indicators. What I mean by that is all of us, everybody in this room, whether you're flying robots in space, in the ocean, over the air, we're producing huge volumes of information. The relative value per unit of that information is very low because there's so much of it. However, there's a concurrent AI, machine learning, computer vision revolution that's also underway, which it looks to correlate changes across those data sets to find the relevant insights. So there's a major information revolution going on. There's also a secondary major insights revolution. Interestingly, next week I'm going to the UN to a major AI for Good summit that they're doing in Geneva. It's all about this layer as it relates to how do they extract insights to drive better value for the SDGs. So it's interesting that conversation is happening concurrently. When you have stable insights over time, eventually you can start to build new indicators. And by indicators, I mean big indicators, indicators that are predictive, much more complete, much more comprehensive, much more predictive. And if you have a reliable indicator, you can begin to build new kinds of financing instruments, new kinds of policy and technology instruments. And I think ultimately this is where we're going to go, is all of what we're doing in this room together is sort of here, and we're starting to scratch up here, and our future is up here. And the relative trajectory is from a lot more information to a lot more value as we get up to these sort of instruments that can guide behavior at scale. Okay, so what do we mean by that? Well, one of the benefits we have at Planet is we have all the data in one place. So we can begin to run these analytics, begin to produce these indicators. And I think everyone in this room is going to be involved in that in the future, but I'll just show you the kinds of things we're seeing are things like using this kind of very high frequency satellite data combined with very sophisticated ground data and that kind of analytical layer in the middle to produce economic indicators that are better real-time economic indicators of activity on the ground that are collected in the kind of annual cycles in which government, quarterly cycles in which governments, if they're really good, collect this information. Similarly, we're just doing a huge project with Stanford in Kenya with 1 Acre Fund, where we're producing in-season predictive agricultural yield indicators for smallholder farmers for maize. So that is, before the crops are done growing, what is their likely yield to be in a way that can both ensure that we don't have food insecurity, but also that we don't, that we can use as a kind of proxy for the building of financial instruments and helping, create the kind of financial structures that help people lever out of poverty. In Nigeria, there's the other use case, which is the other thing I think is a huge under-heralded use case for drones, which is lowering the cost of randomized control trials. So you're making policy changes in the way in which you grow a crop, for instance, and you want to monitor what the outcome is. Monitor it with drones and monitor it with satellites. And in general, this is the future that we really see coming. It's called tip and cue. That's a term that comes from long-standing geospatial, remote sensing, governmental. It's a sort of fantasy. The idea is that we look everywhere in the world at 3 meters, and we're running rough, broad change detection algorithms to identify where change is occurring. Then, when we see it, when that threshold has occurred, we automatically deploy. We have a second constellation of satellites we recently acquired from Google, which image at 80 centimeters. And then we continue to monitor at that cycle. And then when additional change occurs and we understand what it is, then we task the drones. And we're going to see a lot of this. The one organization that Patrick mentioned that I think is really interesting, that we've started to do some work with, is called BioCarbon Engineering. Has anyone ever heard of them? They're totally fascinating. Yeah, they're running satellite and analytics on deforestation and where deforestation is occurring. Then they're tasking drones that have these percussive seed bullets that they basically shoot at the ground that contain the seeds for nutrients. So they're sort of doing machine gun oriented reforestation, which I have to say is this is the second coolest thing I've heard, other than the UFO experience we're giving to sleepy mosquitoes, where we literally suck them into the air. Can you imagine if you were a mosquito? You get drugged, someone messes with your junk, you get sucked into a spaceship and dropped from the sky, okay? Can we just appreciate that that is going on in the world? Okay, and with that, I will say thanks. That's me with this. Oh, yeah, sorry, one more thing. So we're going to give access to planet data. We just figure out the use case and parameters to all of the flying labs. So we're super excited about working with them. Our goal is to figure out the future together. So let's do that. Thanks.